the designs, what test cases are, the test condition, what the script is, the testing techniques that we use. That's what we'll be talking about much today, just to introduce you and make sure you have a clearer understanding about what the whole thing about test cases. Because you as a manual tester, this is your job. You as an automation tester, this is what you're going to do. This is our main part. When you look for bugs, you also, before you can look for bugs, there are some preps that needs to be done. So all this, we'll be talking and looking in depth of it today. I'll give you much time today to be able to ask questions, and I'm also going to ask you questions. So at any point in time, if you know you cannot hear me, let me know immediately. If you need clarification, just wait at the end of the class. You will get, you can just be or pop in all your questions into the chat. I'll be looking at it severally. So that's me for tonight. So tonight we'll be talking about what test cases are, what the test conditions are, what the test case design technique are. Last, hello? Can you, who is that? Sorry, please, can you all mute yourself?
We can't hear you again.
Yeah, you need to unmute.
Oh, okay. Hello, can you hear me now? Good. So, like I've said initially, I've talked about all the topics we're going to talk about. So, for tonight, I want us to start with the testing technique. I just want us to have an in-depth of it. Since that we have been talking about different principles, different methodologies. Yesterday we talked about in depth of SDLC, STLC, how this really affects us as testers. Now, bringing STLC to life is what we are going to talk about today. Some of the 6 phases of STLC, test case design, planning, requirements, and all these are part of it. So out of it today, we will be looking about the technique of writing or designing test cases. So that's what we are going to be talking about today. I'll give you various examples. You can ask me questions about it so that you can understand the techniques. These techniques, they are practically interview questions. As long as your manual tester is an interview question. And everything we are teaching you here, know that yes, they are prone to be asked during interviews. Because when you are pitching, you have to pitch all this along in your speech so that people will know that yes, you actually have an in-depth of what you're doing. So today I'll be talking about what software testing technique is. And software testing technique helps you to design better test cases. That's the essence of the technique. So now you want to let's bring it to our own world. Let's from software, take it away from software. We want to cook food. We want to do normal cooking. For you to cook, you must have learned how to cook. If you don't know how to cook, you need to look at some steps to be able to help you to cook, which means you can take some menu book. Even you are a great cook, if you know how to cook, fantastic. Not all the food in the world you know how to cook. So you need some steps to help you cook the ones that you don't know. Now I'm bringing it back to that word for to testing world, for you to design a better test case, you need some technique. Those techniques are what we want to talk about now. So those techniques is where exactly we are going to. So the main thing for this technique is just for us to help us build some better design, better test cases. Hence, that's the reason for this software technique. So I said, since exhaustive testing is not possible, manual testing techniques help reduce the number of test cases to be executed while increasing test coverage. They help identify test conditions that are otherwise difficult to recognize. With manual testing, automation testing, very good, fantastic, but you cannot do 100% automation. You still have to do some manual testing. You need to do some verification. There are some things that cannot be automated. You will be taught how to know which ones are automation candidates. So with manual testing, it's easier for you to be able to explore and do a lot of things. Hence, the reason for all these techniques, to make your test cases look good, to make it better. That's the reason we are driving into it. So test case design. So test case design are predominantly classified according to their nature of testing. And they are classified into three types. One, we have the specification-based design technique. We have the structure-based design technique. And we have the experience-based design technique. So this design technique, they are categorized into three parts. Specification-based, structure-based, experience-based. So with this, let's go to how to create our test case design. We have said the three categories are specification-based design technique, structure-based design technique, experience-based design technique. From the name, you would understand, you would have been having an idea that, oh, what this means: specification, structure, experience. So all these are the three categories. So let's start with the first one. Specification-based design technique. This is popularly known as a black box design technique. In this design technique, the test cases are written by taking the client's functional requirements. That's hence the name of this. Specification is also a requirement. It's also like a user story. It's also like BRD, business requirement document. That is specification based. So you are going through a document to be able to do it. So we've got the client's functional requirements and specification into consideration. So that's what we use when it comes to specification-based technique. But there are ways we now break down this technique when it comes to specification-based. And these 5 techniques are very, very key when it comes to designing your test script. It is necessary that you have an understanding of this technique. And the first one is equivalent partitioning. The second one is boundary value analysis. The third one is decision table technique. We've got the state transition testing technique, and we've got the use case testing technique. So always remember, the test case design technique is divided into 3 parts: specification-based, structure-based, we've got experience-based techniques. 3. But each of them have what actually they stand for, how you use each of these techniques. So if you want to use specification-based technique, there are things that you need to use that will be able to help you to use this specification-based technique. Most of the time, we are working in agile environment. We are going to be using this specification-based technique. And the 5 that I've mentioned, equivalent partitioning, boundary value analysis, decision table, state transition, and use cases. You will see how it comes to play when it comes to our test case. When we start designing it in full, you will have a clearer understanding when I bring more examples into play. Let's take the first one, equivalent partitioning. Equivalent partitioning. We want to partition things into different places so that we can test each subset and know that, yes, we have fully tested everything. So equivalent class partitioning allows you to divide set of test conditions into partitions which should be considered the same. This software testing method divides the input domain of the program into classes of data. So let's take a wider example. Take it out. Let me bring it to a practical knowledge. Let's give an example. We've been talking about we want to log in into Blue Sky. When we wanted to log in into Blue Sky, there are various ways when the application was under test. So it means by that time it wasn't live. Before it went live, there are different permutations, combination of testing that was done on the website before we could bring that website to life. So let me take that functionality of login. We want to log in with username and password. Look for anything that has login. As long as you want to fill an application, you want to access a website, you need a login detail. So let's take login as the general one. Maybe in the requirement that you got from the business analyst, for your password to be valid, there are certain things they expect it to have. So in this example, the requirement for your password to be valid is it should contain a minimum of 8 characters, should be alphanumeric, and contain at least 1 special character. Special character, so let's start. The requirement for it to be valid, minimum of 8 characters. So 8 characters. It could be my full name, Olayemi 1. I take it. That's 8 character. Because Olayemi is 7 plus 1. 7 letters plus 1. But it hasn't fulfilled it. He said should be alphanumeric. Of course, it's alphanumeric because I've got letters and I've got number 1. And he said it must contain at least 1 special character. I don't have any special character. So I can use special character like exclamation, asterisk, full stop, dollar sign, pounds sign. So different special characters can be used. So for it to be valid, that character, these are the conditions we are actually talking about now. This one, for that to be valid. So I'm taking that example as that. So now, what I will do now in the next case is that for me to get for us to put this together, let's take the first example. I've used my full name, Olayemi 1. That's one example. That's one test data. Take the second test data. I'm not going to use Olayemi 1. I'll use Olayemi 1 exclamation. That's another condition. Take another one. I might start OL, my A. I can use it as at sign and use it as my special character, YEMI. I use 2. That's another condition. I can bring 10 of it out. So let's take those 3. Those are different edge cases that we want to test. In this case, the input can be different equivalent partitioning, such as valid inputs that makes the specified character invalid. So my first one that I've done, Olayemi 1, it doesn't meet the valid password because Olayemi is all letter and number. So, but this case says for the requirement of your password to be valid, it should contain minimum of 8 characters. Yes, it's true. It has 8 characters. OLAYEMI is 7 plus 1. That's 8. Correct. Should be alphanumeric. Fine, it is. Letters and number. Now, it must contain 1 special character. It fails there. So it means that password is not valid. Then the next thing is that I put the one that said Olayemi 1 exclamation. The Olayemi is 8, is more than 8 because that's 9 characters. It's got alphanumeric and that's alphanumeric, that's 1 as the and also letters, and it's got a special character which is exclamation mark. That is a valid scenario. Now, always remember when you are testing happy parts, you must do a valid scenario. You must also validate invalid scenarios. Positive and negative testing to validate that application, the happy part might work fantastic. Where you can break the system is you using more than the edge cases. And that is why we need all these techniques to help us to be able to test it. Now, my expectation most of the time, if you put the 8 characters, Olayemi 1, most of the time it will take it. If the code is not properly in sync and it didn't follow all the rules stated in the requirement. If you find it in the requirement, it means this rule that it says for a valid password, it must be validated. So at that phase, I check all those, all your negative testing can be different formats. It says for it to be valid, it should be minimum of 8 characters. It must be alphanumeric. 8 characters, 1, 2, 3, 4, 5, 6, 7, 8. Their characters. Is it alphanumeric? No. I should test that one too. That's another part. So that's the way you do all this combination when it comes to partitioning. Now, that is different ways that I've collected my test data to be able to test when it comes to equivalent partitioning. That's an example. Let me take you further down to see more of it in numbers. Now, this is an example. Let's take this example. My first input conditions are valid between the 1 to 10 and 20 to 30. Listen, 1 to 10 and 20 to 30. So 1 to 10 is the valid part. That's my requirement. My requirement says, my input condition says, it must be from 1 to 10 and 20 to 30. So 1 to 10, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Stop there. And 20 to 30, 20, 21, 22, 23, to 30. That's what the expectation of this example is. So let's break it down. I can break it down more than 5 cases. So for my first part, I will start from, let me take it because it says 1 to 10. Let me start from minus 1, minus 2, minus 1, 0 to 0. Or maybe from minus something to 0. That's one scenario. It's not a valid one because that's not where my input condition wants it to. It's an invalid scenario. Now my valid scenario is between 1 to 10. So I can take any part. For my invalid, I can take any part from 1 to 10. Anything I test within 1 to 10 is a valid scenario. Now they use the word and. It's not continue, it's and. They stopped at 10. They rested and started from 20. So I will go to the next one too. I need to validate that there's nothing escaping from 11 to 19 here. So from 11 to 19, I would test it again. That's an invalid, that's a negative test. I need to test that part too, to be sure that nothing escaped. So any number I pick there should suffice. So it should be within 11 to 19, something that's invalid scenario. Now, another valid scenario is from 20 to 30. Any number I pick from here should be a valid scenario. And the last of it all will be from 31 to infinity. Any number I pick from there should be invalid. So these are the 5 partitions that I have done to ensure that all variable possible conditions are fulfilled in this scenario. Now let's select the values. For the invalid one, if I want to test, I can't test number 1 to 10 because this is just because it's small subset. It could be 1 to 1 million, 1 to 2 billion. So I can't start testing number 1 to 1,000 to 10,000. I won't finish testing in 2 years. So that's why I need to pick it to ensure that, yes, it's being divided correctly. I have touched every edge case to be sure that, yes, it works. So now let's take a selection. For the first one, for my invalid scenario, from minus to 0, I took a subset of minus 2. You can take minus 5 if you want to. It doesn't, even if you take 0, it doesn't work. So that's an invalid scenario. Now my valid scenario, I took 3 from here. I can take 5, I can take 7. So any number within 1 to 10 is a valid scenario. So this is my valid scenario. Another invalid scenario is 11 to 19. I took 15 here. You can take 17, you can take 11. So it actually depends on the number you want to test. I take another valid scenario, 20 to 30, 25 was the one I chose here. And the last of it all was 30 today. I just took 45. So if I'm going to test, I test these 5 to make sure that all possible combinations have been tested. Hence, example of equivalent partitioning. That is the logic about equivalent partitioning. Now let's move further to the next technique, which is boundary value analysis. It's called the BVA. BVA, boundary value analysis, is based on testing at the boundaries between the partitions. So it includes the minimum, maximum, inside, outside. Check all the boundaries. Like if you are in, if you want to, you are in, we are in Britain, we are in England now, an example. We want to test all the boundaries. So I'm going to go outside England to test, check. Let me, aside from testing from England, I can test the ones that are between the boundary. Check Malta, take Portugal, take several places to test as my edge cases. They are within the. Also, I will come into England and also take Edinburgh, take other places, just test it to be sure I've taken all the possible boundaries have been put into consideration. Now, in this case, the values from the lower boundary and upper boundary are considered. Let me take another example before I simplify the example. An application accepts 4 digits numeric values. Here at the range is from 1000 to 999. So you as a tester that you want to use this technique called boundary value analysis, the case here will be you want to test every possible input and output, starting from this is 1000. Look, do something. When you minus 1 from this 1000, it gives you 999. That's one edge case. That's one you test because that is outside the boundary. Whatever is between 1,000 and 9,999 is within the boundary, is inside the boundary. I am still in United Kingdom. I'm still in England. So I want to test something outside it. That's when I go something 999, and I can add minus to take 1, and I can also exceed, add 1 to it to make it 10,000. That's the edge you can test when it comes to boundary value analysis. Let me make it more simpler. These are big values. So let's take it 1 to 10. 1 to 10, simple number. 1 to 10 is where we want to analyze this technique using boundary value analysis. So what you want to do here is you can start taking it from -1, 0, 1, 2, 3. Stop there. Again, if those 4 or 3 conditions works perfectly, it means it's going to work for every other one. That is what we are trying to evaluate here, because we've got trillions of numbers that we need to validate. So you have to, this is where you have to think that we want to prioritize, we want to know the exact thing, and we want to make sure that we have tested all the possible edge cases, combinations, different things that will let you know that yes, proper testing has been done on the application, on the data you are actually working on. Now, the next set you can take, you can start from 8, 9, 10. Now you can take 11, 12. Once you test those values, there's every possibility that if it works, it's going to work for every other one. That is the logic about boundary value analysis. Now, it's quite confusing. You say equivalent partitioning. You saw the example I gave you. I never went out of the boundary. I was within that boundary. But in boundary value analysis, I needed to go further to test it, so that I have taken everything that needs to be tested there. So this technique work hand in hand. Don't forget, interview question. What is the difference between boundary value analysis, BVA, and also equivalent partitioning most of the time? So we'll go, this drives us to the next technique, which is decision table. Decision table, this is more of you working on an application. You have entered various combinations. You would have done that prior to it, and you click submit. So you need to know what combination will work. What is the valid scenario? What is the invalid scenario? So let's say a decision table is known as a cause effect table. This software testing technique is used for functions which respond to a combination of inputs or events. For example, a submit button should be enabled if the user has entered all required fields. That's when the submit button is enabled. If you want to do a registration, before that registration button is enabled, you must have filled all the mandatory fields. Then you get the registration. If you don't fill it, it will still be grayed out. You won't see anything there. It will be grayed out. So the next thing is, what is the first task you are going to do in this one? You identify all the functionalities, you know what this depends on, what the combinations are, what are the subset. Then you'll be able to say, this one should work, this should not work. This should bring out the submit button. This should not bring out the submit button. Let's take an example. Let's take it. These are my inputs. In my name, I didn't put a name. That's why you see the F and T here false true. So false true. That's what it means. FT, false true. So take the first name. So we've got my input value. This is what I've inputted. So for me to be able to get the combination for the submit button to be triggered, for the submit button to be grayed out, what I did is that my first rule, if you enter name, if you don't enter a name correctly, and you don't enter an email correctly, and you don't enter a message correctly, that's first rule. Now, this output is my expectation. Should the submit button be triggered? Should it be opened? Yes or no? So if you don't enter these three, definitely you've not given us the true identity of who you are. So definitely submit button should not be enabled. So I put a false. It shouldn't. Now take another name. That's another combination. I've put the name, correct name, but I put a false email. I put a message. I didn't put any message, which is also, it shows that these two mandatory fields were not filled. So I've got true, false, false. My expectation, that submit button should not still open, because in my requirements, I've been told that email, message are necessary. They are must have. They should be there. But they didn't have it. It's only the name that is valid here. So hence, submit button should not be enabled. Now, this time around, in rule 3, I look at it. Okay, what else are the combination? I put false name. I put true email, my correct email, and I put a message. I didn't put any message here. is false. So I'm expecting that not to be triggered. Now I've put correct name, Yemi. I've put my correct email, yemi@test.com, which is fine, but I didn't put a message. My expectation is that as long as he still got an F, then it should not be triggered because this is also a mandatory field. So this time around, I tried another combination to put my name, rule 5, name, false, no name, no email, but correct message to say, I love testing. That's the message I put there. But unfortunately, it's still going to be grayed out because I've got 2 combinations of F, which are mandatory fields. Sorry. So the next one is rule 6 states that I've got name, correct name. My email is false, no email. And the last one, I've got the right message. But this email is still needed, so it's false. Rule 7, I've got false name, false email, false name, true email, true message is still false. Now, the happy parts. My name is correct. My email is correct. I've put a message. Hence, that submit button should be enabled. That's a true example of decision table technique. It's just like a course where you are trying to look for every combination, permutation combination that will trigger for you to be able to break a system at every phase. With this, I can tell you these all 8 rules, if it's normal development phase, if it's from a greenfield project, even if it was an already existing project, one of these might fail if it's not been tested. If it is different rules, it might fail. So that's the way this works. Now that leads us to the next one, which is state transition technique. In this technique, I know you're wondering that why am I taking so much time on this technique? Because after this time, this technique will now come practical to you. That's what you are going to be using when it comes to designing your test cases. When you're writing your test cases, when you're designing it, these are the techniques that's expected for us as testers to use. So take this. In this technique, the application is tested using graphical representation of the different transition states of an application, which are further dependent on various features and functionalities of the application. It is primarily based on the state machine model. Let's bring it back to a clearer view. Let's take an example. An example is that if a user enters a valid password in any of the first 3 attempts, the user will be able to log in successfully. Because most of the time, when you want to log in into an application, you've got 3 or 5 attempts. So let's say the first attempt, you know your username, you know your password correctly, you'll be able to log in successfully. That's the expectation. If the user now have invalid password, in the first, second try, the user will be prompted to re-enter the password. But when the user enters password incorrectly the 3rd time, there will be a consequences for it. There will be an action. Is it that the account is blocked? Is it that you are told to log in back in 30 minutes or thereabout? There will be a message pop up to tell you this is the action you are going to do. Let's take it to a pictorial world for you to get a normal understanding. Let's start from here. We start here, me as a user. So I've been asked to enter my PIN number, correct PIN number. So in my first try, happy parts. I enter correct PIN number. My expectation is that access was granted to me because I knew my PIN number 1234. So it was granted. In my second try, this is the happy part. So let's start. The first try, incorrect PIN. Okay, that's fine. The second try, incorrect PIN. Fine. In the third try, I got the prompt to tell me, be careful. This is the third time. After the third time, your account will be blocked. I try again. The third time, incorrect PIN. My account is blocked. Happy part, account blocked. Access granted, account blocked. That's true scenario that we understand. Now let's add some caveat. Maybe it's the second or third attempt. So now I've entered first try, incorrect PIN. That's fine. My second try, oh, I remember now. That's the PIN, correct PIN. When I entered the correct PIN, I was granted the access. Fantastic. So let's say again, I start again. For my first try, I had incorrect PIN. My second try, I had incorrect PIN. Oh, in my third try, oh, that's the combination. I remember now. Correct PIN. I'll be granted an access. In a nutshell, this is how the transition, the state transition technique is used. So all these things are just on a practical basis when we are testing. So that when you're testing login functionality, these are edge cases that you need to know. So now, if, for example, you have been drafted into a project to start working on the project and it involves logging, you now know that you could ask the question there, are there various attempts to log in? Has that been captured in the requirement document when you were doing static testing? You should review that. If it's not been captured, you can ask the business analyst, is there a reason why this has not been captured if people have login? If they say, oh, we just want to make it friendly, they should give you an explanation why an attempt is not needed. If it is, then you need to test it properly to ensure at the third time what happens at the fourth time. So record each of the trials, each of the attempts to ensure you've got good coverages when doing this. So that leads us to the final part of the technique, which is use case testing technique. The different scenarios that an end user will encounter when using an interacting with the application are tested in the technique. So all the techniques you have been doing, mainly they are the use cases, like the actors there, how we are being testing. So how all these various, what the user are going to encounter and what we have tested in technique 1 to 4. So this is it at the final end. So that is the 5 techniques that we have under specification-based technique. So the specification-based design technique is a key one. Please, let's go to the next one, which is the second one out of, don't forget, our test case design is 3. I've just finished 1 out of it. Now I'm bringing it back to the second one. That first one, I needed to go through it step by step because it is necessary. It is mandatory when you are designing your script to have that. So now that leads us to structure-based testing. What is structure-based testing? It deals with an application, internal structure, and the architecture. Here, the source code used to develop the application is tested. This is where codes, we are talking about codes, Mainly at this phase, we are drifting and bottling down into automation testing. Therefore, in this case of structure-based testing, a good understanding of the code and its internal flow are necessary in order to be able to design the test cases. So you can see how test cases are coming to play now. Manual part of it, we have done it in terms of specification based. Now we've not forgotten that it could be automated. How can testing be done? If you can remember, manually, automatedly. I've taken you to the manual rigor, which the same manual testing I have done, that I've done in specification based, is also needed when you're doing automation. So at this phase with code, it's needed for you to have a clear understanding of the code. Structure-based testing is also known as a white box testing or glass box testing. The quality of the code is analyzed based on different factors such as code coverage, readability, maintainability, security, or bug vulnerability. We also do reusability, refactoring, etc. when it comes to code, when you're coding. So all these are put in place when it comes to structure-based technique. Remember, structure-based testing technique deals mainly, you must have a good understanding of the code when it comes to structure-based technique. Now, this is also just a clearer view for me to make you understand and bring you back again so that you don't forget what I have told you initially. You should know 5 specification-based technique: equivalent partitioning, boundary value analysis, decision table testing, state transition testing, and use case testing. I will keep reminding you so that you don't forget it. And the second one is a structure-based, which I've just talked. So specification-based is black box because we can see it. We can, all the examples I gave you are things that you can see. Black box is something you can see physically. White box are internal. That is why it's code-based. So that takes us to another category of software of test case design. This is experience-based technique, error guessing, exploratory testing. Experience-based. So in the experience-based technique, that's the third one that we have, are those that fall back on when there is no adequate specification from which to derive specification-based test cases, or no time to run the full structure. Look at the word experience. So for example, you can be in a project where there are no requirements, where there are no clear specification. So they fall back on projects, what they have done previously, so they can use it as part of it. For example, maybe in release 1, we tested login. The first release, so their login in Blue Sky has been tested correctly and is live. So everybody is now public and people are already using it. Now, in Blue Sky, there are other sub-projects. Say, for instance, we've got Prep Major, we've got Long Week Project, we've got things. There are various projects under blue sky, inside blue sky. I'm giving it an example. Maybe I also have a project there. So now the same thing is that we don't have requirement for one of the projects. And they also have logging as one of the functionality to be tested. We could use the experience of what we have previously. You as a tester can use that experience and use it to incorporate into the new project and say, oh, we did login. We said it should be alphanumeric. We said it should be this. So you can reuse those test cases at this point, using your experience to test the application, even despite there are no specification. And how is this big guy, this third person out of the techniques that we have been looking at? This experience-based technique, the third guy, he has two people, two ways that he always try to achieve it. How does this person achieve it? He uses error guessing or he uses exploratory testing to achieve it. So experience-based technique is the third one out of where we are coming from. We've done the specification-based technique. We've done the structure-based technique. Specification-based technique is black box testing. Structure-based technique is white box testing, which both of them, then the last one is the experience-based. Now, this experience-based, you will look at it. How am I going to do it? Okay, what technique can I use to do it? Now, it's got error guessing, it's got exploratory technique. Now, let's just dive into error guessing. Error guessing is a very simple technique that takes advantage of a tester's skill, intuition, and also experience with similar application to identify special tests that may not be easy to capture by the more formal techniques. So, as I've said it, that is just maybe you've worked on the similar application, which is the Blue Sky login. Now, the same project, you want to work on a similar one, but it's not Blue Sky this time around. It's my project, Yemi's project. And also, it has a login, the same feature. I can use that, adopt the same system, the same process, the same procedure, same test cases to just try. And also, we use tester skill at this point. We are going to use our skills. Oh, yes, this is tester skill. Let me look at it. I should be able to do, will it take 3 attempts? Is there any reason why you don't want to add the 3 attempts? What are how we know a valid scenario, a valid password? What are the criteria for it? So it must be 8 character, it must be 9 character, it must be alphanumeric with special character, all the likes. That is the way you are just using those errors, your skills to bring things alive. That's what error guessing is all about. Now let's talk about this exploratory testing. What is exploratory testing? Exploratory testing is a technique that combines the experience of testers with a structured approach to testing, where specifications are either missing or inadequate, and where there is severe time pressure. So mainly what exploratory testing does is more of you exploring the system, explore, play with it, understand it. You already have the system. We don't have specification. It's inadequate. Play with what you have, gain an understanding so you can explore the system. That's all. That's the way exploratory testing. But let's dig down into it just to know. Let's talk more about these two guys. So that's the third person I brought alive. This person is the experience-based testing. And these are his two friends. Error guessing, exploratory testing. Just like the way we did in experience-based. So I'll move further. Let's take error guessing. So error guessing, I've talked more about error guessing, the reason why we are, what is used, we use the tester skills. We can also use different, we can get an understanding from different releases, different applications that we have done previously to be able to use this error guessing testing to be able to test. The technique counts the list of possible errors or error-prone situation. Then tester writes test cases to expose those errors. So that's where when we are doing error guessing, we are looking at different combinations. It's kind of a good exercise when it comes to testing. It helps you to, that's in places where requirements are not accessible. We don't have requirements. There was no requirement documentation. So we are all, it's more of error guessing. You are just guessing that, oh, this is how we should work. This is what we should do, this and that. So at that phase is when we actually use this technique. So what are the guidelines if you are going to use error guessing? What are the guidelines? What do you need to, what are the things that you need to do? The test should use the previous experience of testing similar application. You can see, uh, when you are using error guessing technique, just go to an application you have worked on before. Login, registration. Then use the same format, same technique to be able to do it. Understanding of the system under test. So you have a better understanding of the system that you are testing, that you want to test, that you're testing. Knowledge of typical implementation errors. Remember previously troubled areas. So lesson learned from the first release. It might be, oh, subsequently there was some data missing, this and that. You use those lesson learned also as part of your, or as part of the guide when you are doing error guessing. Then evaluate historical data and test results. So evaluate them. Look at what you have previously. Oh, this is it. Just go back, do your checks to ensure that test results reporting at this phase are well documented. So these are just the guidelines when it comes to error guessing. Now, let's take exploratory testing. Exploratory testing is a type of software testing where test cases are not created in advance, but testers check the system on the fly. They may not down ideas about what to test before test execution. They focus on exploratory testing. It's more on testing as a thinking activity. So it's more just you looking at the system. Okay, for the login, I've not seen the application. Yeah, previously, just let me see. Let me use this combination. Oh, fine, it works. This is what is expected. I log into it. Oh, the browser is launched. Oh, I can see it. What happens here? Okay. Okay, I'm looking for the course. What course? Oh, it's QA course I'm looking for. Oh, that's it. Add it to cart. Let me now go into payment. Oh, that's fine. Where are the payment? I don't know what is happening. I can navigate to another tab to look, oh, what happened? This is just that I'm playing with that system. I'm exploring it. I don't have an idea of how Blue Sky works. I don't know how the application works. I don't know how the website is working. So I'm just exploring, testing it to see how it is. Exploratory testing is widely used in agile model and is all about discovery, investigation, and learning. So that's what exploratory is about. You're learning the system, you are exploring the system. It emphasizes personal freedom and responsibility of individual testers. So, what is the technique? How do you use exploratory testing? The technique is not random testing, but is ad hoc testing with the purpose of finding bugs. Is ad hoc testing with the purpose of finding bugs. That's the essence of, that's the way you use this technique. So at the face, you might be looking at, oh, what is, how does this now work? If you tell me that this thing, so it's just ad hoc testing is just a process of doing, you are doing it manually in order, looking at it, it's not a structured testing. Is unstructured, is an informal test. That is ad hoc test. So you are just aiming. Your aim when you're doing ad hoc testing is that I want to break this system. I'm just playing with it. Most of the time, when you don't know the application, it's easier for you to break the system quickly because you'll be testing several things that is not meant to be on the application. By that time, the application might crash. So at that stage, you have broken that system. You have broken the website because once the application crashes, then they will know that, oh, it means if we forgot to add this as part of our code, then it's being taken back to the developer. Hence, the reason for ad hoc testing. It finds possible defects when it comes to ad hoc testing. So that's it. It's structured and rigorous. It's very rigorous because you have to be thorough when you come to you do exploratory testing. You are bringing all your experience in, looking at the system. Oh, how does this work? How is this being done? So is structured and is rigorous. To be honest, it's not an easy task when it comes to it. So that's about exploratory testing. Is also, it is an exam, it is not a technique, but it is an approach. This is where exactly it is not a technique, it is an approach. So it's an approach for you when it's not that exploratory testing, you say, oh, this is how to do exploratory testing. You must go to the login and do this. No, it wasn't stated. It's just an approach. It's not a technique. So it's just for me, take the system, explore it. That's the action. That's what you are meant to do when it comes to exploratory system. So that's it about that technique. So that leads us now further to understanding test case design. It takes us more for us to get more understanding on some features when it comes to test case design. If you can see, there are three main things that I want us to, when it comes to designing scripts, there are things that you need to have a clearer view and understanding so that you will know when you start designing your script how to use this. The first one is test condition. Test condition, a condition. The second one is a test case. And the last of it is test procedure specification, which is known as test script. So let's take the first one, condition. It's a condition. Test case. Then we're talking about the script. Let's take it at large. What is the test condition? Is an item or event of a component or system that should be verified by one or more test cases. So let me take an example. In the example, I will take a patient. Let me use the example of a patient so it's clearer. In that patient is gone to the doctor. And the way it's done is that you can't just go to the doctor directly. When you get to the hospital, you'll have to tell them at the reception because you don't even know the doctor you are going to meet. So you get there to say, patient A, good evening, receptionist. I want to see the doctor. And the receptionist would say, good evening. What do you want to see the doctor? What is your details? And the patient A will give their details to say, I'm this person, this is my name, this is my date of birth and everything. We pull up your record. Fantastic. Now, when he pulls up, okay, you're here. We can see your details. What do you want to see the doctor for? What is your test condition? Why do you want to see the doctor? That's your test condition. So the patient A will say, I want to see the doctor because of stomach pain. So the condition here is stomach pain. Don't forget, that condition is what patient A has come to see the doctor for. That ends that condition. Now let's move further to the test case. What is a test case? A set of input value, execution preconditions, expected results, and execution postconditions developed for a particular objective or test condition. So if you look at the first one, it says an item or event of a component or system that could be verified by one or more test cases. Now take this away from software testing world. Let's take it back to patient A. Patient A is still at the reception. He's been told to sit down after he said stomach pain. Now, before the doctor calls patient A, he knows the next person on his queue is patient A. So the doctor would have looked at it. Oh, patient A, he or she came for stomach pain. Quickly, let me get my preconditions. Let me get what's the questions I'm going to ask him. Let me get my test cases ready before I call this. So it starts. What could cause stomach pain? The doctor will look at it. Did you eat anything that upset you in your stomach? That's one condition. That's one test case. So he needs to know he has come for stomach pain. So he now needs to start breaking what could cause that stomach pain step by step. Did you take anything that upset your stomach? First test case, he was going to ask. So his expected result is that yes or no, I took something. So he can say if it's yes, then he knows what he's going to do. Did you drink anything that could upset your stomach? This is it. Third condition. Do you have anything you are allergic to that can upset your stomach? Those are the three conditions. He could write it up to 10. Let's take that three conditions. Those three test cases. So the doctor has prepared his test case against the stomach pain written in the patient's record. The doctor has not seen the patient. He doesn't know the patient. Now the doctor pressed the bell for the patient to come in. Now he has prepared that test script. the test case down. So he's done the condition, and under the condition that was taken by the receptionist, he's done test case against it. And he has written his expected results. Now, patient A, can you come in? Is in to see the doctor. Let's stop at that place before he meets the doctor. Let me stop at that place where patient A has gone in to see the doctor. That's where we are. So what we are going to do is look at another example, bring it back to this world. I'll take a login scenario again. In a login scenario, we can have valid username and password, invalid username and password, valid name and invalid password. So if you look at this example, that reminds us of a technique that we worked on. The technique was equivalent partitioning. That's it coming to play again in my test case design. So that's an example. So you can have a valid username, a valid password, happy path, invalid name, invalid password, invalid path, valid name, invalid password, invalid path, invalid name, username, and invalid password. It's invalid. So those are the four. Apple tree here, there are four edge cases that I could look at when it comes to that. So that's our test case. Now, what is test procedure specification? A sequence of actions for executing of a test case. So what it means is a test script. Don't forget, I stopped you at when patient A has gone in to meet the doctor. Now, when patient A has gone in to meet the doctor will now ask patient A, it's three possible questions. Did you eat anything that upset you? No, I've not had anything today. Okay, that's his actual result will be no. So that one did not work. Did you drink anything that will upset your stomach? No, doctor, I didn't. So that's one of his test case. Then the final one is that, did you do anything? Or are you in any place that really upset your stomach? Oh yes, doctor, I've got this, I've got that. That test case is validated. So that's the happy one it went through. So that's working as expected. So your actual result has been stated there. You've got your pass or fail. And that is what forms your test script when it is executed. Let's dig down. So what are the advantages of test conditions? More flexibility in relating other test work products, better and more detailed monitoring and control, because you have stomach pain. That is what patient A has. That is what we are testing. So we know our test cases, test condition is all about stomach pain. So we can, it's kind of clear, we know that yes, this is what is working. We can monitor it, we can control it, we can look at it till the very end. It contributes to defect prevention by occurring earlier. So with all those possible scenarios by the doctor, If there's any issue, if those three conditions were not fulfilled, then we could know that, oh, then we need to add some more things. Earlier detection, the earlier defect preventation. So you can prevent bugs earlier. Relating test works. Relates testing work products to stakeholders in terms that they can understand. So now, if you go to stakeholders, they know, oh, stakeholder, okay, for patient A, they tested for stomach pain. Okay, that makes sense. They don't want to read everything, but they know, yes, it's easier. It's a capture. You have done you've mapped your test case against the requirement. So they know, oh yes, in the requirement, we really asked for stomach pain. Oh, it's been covered. So they get a clearer understanding that, yes, this is what it influences and direct other testing activities, but also other development activities. So with this, it drives them to know, okay, aside from stomach pain, what else could be wrong aside from stomach pain? Okay, we can also try to test for another thing, maybe a pain, which won't even upset the stomach. That is already an idea. It's not only for testing, but development team, which also includes the analyst. So they all can get a better understanding when they have the condition. It will lead them to other edge cases that needs to be tested. Enables test design, implementation, and execution to be optimized by more efficient coverage. Basis for clearer horizontal traceability within a test level. So now, what is test cases? They are often predefined tests set of instruction addressing the steps to be taken in order to determine whether or not the end product exhibits the desired outcome. So those test cases that the doctor took are for it that when I see the patient, I would be able to know exactly what the outcome of whatever is wrong with the patient. But if I did not prepare as a doctor to see the patient, I won't know what exactly to what will be diagnosed or what I can give to the patient to help him. Hence, I need to prepare those test cases down. So the instruction will make me know that he said in him that he already has some stomach upset previously. Is because I asked those questions. If I didn't ask the question and he comes and say I have stomach upset, and I just take any medication, I give him paracetamol. Does it stop the stomach pain? No. So that's the reason that I need to build proper test conditions, proper test cases to be able to validate whatever is wrong with my patient. So this instruction may include predefined sets of input conditions along with respective results. However, in order to be thorough with one's testing, one could often end up with too many test cases, of course. So because we want to test and we want to be thorough when it comes to testing a condition. You might have a lot of test cases, a lot, and that happens most of the time. But it's not that it's going to be, we break things down to do it in high level, but of course, that's one of the ways you can design your script to be, because you're going, of course, there are many test cases. I've just talked about stomach pain. I've just got that three. That three is just because I put the caveat there. There are several conditions that I could look. There are several cases I could look to derive the stomach pain. So this test case design technique helps create effective test cases covering the various features that determines the quality and value of a product. Writing a good test case. I had to use the word writing instead of design so that you can get a clearer view and understanding of what it means when I say design. Is the same thing as writing. So writing good test cases, as far as possible, write test cases in such a way that you test only one thing at a time. You test only one thing at a time. Don't complicate your test cases, because test cases is not meant to be run by only you. Other testers, people can help you to test. Because when it is too, when you overlap it, you complicate it. So, for example, I want to log in. The only thing I need to know, go to the URL to the endpoint, www.bluesky.com. Click on, enter username. Click on sign in. Sign in page is displayed. That's my expectation. Enter username. Username is entered. That's my expected. Enter password. Password entered. Enter a valid password. Password entered. Then the next thing is that click login. I enter. Now give it to anybody. Simple, short. The only thing I want to do there is login. Now it's not for me to say, before you log in, while you're logging in, don't log in yet. Wait, go back again, attend to the. When you complicate things for people, it's very difficult for people to test it. And you as a tester, the major thing that you need to do is you must make sure any test case you're writing is clear, simple as possible. Let it do just one thing. Test cases that are written that you do multiple things there is not allowed. It's not allowed. It's not a professional way of writing it. When you jam pack a lot of things, it's difficult to test it. Give an example. If you want to test just registration, in registration, there's a first name field, there's last name. If you put everything into one, you find out that if one field fails, you can't go further. The whole of that test case will fail. Meanwhile, you could do registration, you could do login, you could do different features without it wanting you to do an end-to-end. So what I mean is that, for example, you write a script to say, test the whole of Blue Sky application. That's your script. Test the whole of Blue Sky website. Simple, and you end it. That application it can't be live. Because if you start with login, you are not able to log in. That's a bug. We raise that one. We'll wait there. No test case to back it, nothing to do it. So we can't move that application. It's failed. Even if I'm able to log in. And when I log in, I can't find a feature there. I'll fail that test case. We start from the beginning. We can't deliver that test case. Nothing is working there. That's what I will tell you. It is not working. Because you said test the whole of Blue Sky application. Yeah. I'm testing it. So now it's not working. It goes back. Yes, but if I've done registration is working. Yes, one of my scripts has passed. If I do login, another one has passed. If I do this, so that's the way it is done. Don't overlap things. Then ensure all positive scenarios and negative scenarios are covered, underlined, not only the happy parts, negative parts too should be tested. So language, write in simple and easy to understand language. Click on sign in. Sign in displayed. Don't start telling me signing it should be displayed. Is this signing is no. Simple way. Click on sign in. It's an instruction. It's an action for you. After you click on sign in, the step that you're, then the next thing is, what is your expectation when you click on sign in? Blue sky landing page should be displayed. Simple. It shouldn't be more than clear, easy, simple to understand. The next one, use active voice instead of passive voice. Do this, do that. Then the next one is use exact and consistent name of the form, the field. So let's give an example. If in your login, yours is username, you must use username. If it is email, use email. If it is login button, let it be login button. If it is submit button, let it be whatever thing you are saying is what you should use. Don't use username when it's email that is there. You confuse people. Nobody will be able to test properly when it comes to that. What's characteristics of a good test case? Accurate, exact, the purpose, then economical, it must be traceable, it must be repeatable, it must be reusable. Accurate, tell me the exact thing. Sign in. Click on sign in button. Sign in page displayed. Enter user, enter email. Email entered. Enter password, password entered. Click submit button. Blue sky landing page is displayed. That is it. Accurate, precise, economical, no unnecessary steps or words. We use something, navigate to the home page. Navigate to this. Give us, don't now say, when you click on the login, then take it from there and log in again and put, no, we don't want that. Use your words exactly, be precise. We don't need no unnecessary step, no unnecessary words. Then traceable, traceable, capable of being traced to requirements. It's a necessity. You must be able to trace it to the. Then repeatable, can be used to perform the test over and over. So you can use it to, you can reuse it. You can use that test case to perform the test all over. Then you can reuse it. So that is characteristics of writing good test case design. What is test script? test script is a set of instructions that is performed on a system under test to verify that the system performs as expected. They can be written in either human language, used for manual testing, which that's what we are going to write, or a scripting / programming language used for automation. So also you as an intern in this time, you are going to use C# as your automated testing. So that's the language you're going to work with. That's the programming language you're going to work with. A test script is a part of test case. And a test case, and a test case can have either a single test script or multiple test scripts. Multiple test scripts are associated with a single test case when each test script provides a different way to test the scenario. So at this phase, you can have several test cases. For example, if you want to test a combination of both, if you're writing your script and you want to do an end-to-end of it, so which involves registration, login, search functionality, you can put each of them in a test case and say, do this. Take a login and test registration. In that registration, you can create a script for that registration. What it means is that, what do you need to register? First name, last name, everything. Put the fields, everything that needs to be validated in that registration field, so that you know that there are multiple. So that's the test case you are meant to validate before you can move further. When it comes to registration for new user, if it's login, then you can put login, enter your email, enter your password, and do that. That's another script in it. Then if it's for search functionality, add this and add this to the class. So that's another script that you can use. So it can be script into script. So you can have several test cases in it. Both manual and automated scripts exist to exercise the test cases. They are used, both of them, both manual and automated scripts. So now, this is how to design our test case, test script in general. All these techniques is what we are going to use to now design our script. But for tonight, I will show you what a script looks like, what a test case looks like, and I'll take a question and answer. The reason why I want you to see it is just for you to have an overview of what you are expecting to see and how you are going to use it, how you are going to import it into the tool you are going to use, how you can also use it directly from the tool, and how also you can use it directly on your spreadsheet. So the next phase is test case. So at this stage, I just took like a normal website. Gift rate was an example of the website I used. So these are the way high-level scripts. This is a test case. And the reason why it's a test case is because we don't have our actual results and our status. Now, the test condition is when, let's take it that this place, this is just test case ID, patient 1, patient A, as I've told you, has come. So the receptionist registered patient A. Now, the condition is come with his stomach pain. Then the doctor started creating the test steps and the description, what he wants to ask her. Is your stomach paining you? Did you eat anything upsetting it? If I touch it, does it pain you? What happened? So did you eat anything that upset your stomach? What is his expectation? Okay, my expectation that yes, he ate something that upset his stomach. Did you drink anything that upset your stomach? It might be neither or. So, do you have any stomach problem before? Oh yes, he might have a stomach problem. So that's your expectation. So that's the doctor. That's what he has prepared. So this is the condition. These are the test steps that he has, and these are his expected results. So hence, the reason why this page is still the test case is because we have not done the execution. We've only implemented. Now that takes us back to our fundamental test process, the phase where we say test implementation and execution. At this phase, we have just done our implementation. We have not executed it. That is the test case. Now, the final bit of it is now, how does a script look? This is a test script. Test script, you can see previously, this place was not filled. Actual and expected results. So it's still just a test case that you've just signed. Now the script is that I have executed it. The doctor has seen patient A, and he has done all his well, and everything seems right and okay with him. Yeah, it's passed. That's the script. If it fails, it's still a script because it's been implemented, it's been executed. So this is how a script reads, because actual result, actual result has been stated because the doctor has now seen the patient. He has called the patient in and he has seen him, and he has the status here with it that makes it good. So that's the way a test script looks like. This is the way we are going to start designing our own script too. And this is the way we are going to end the manual script too. So my expectation is that when we are designing a script, because you have just been put into a group, you cannot execute it. Listen very well. When you are designing a script, your test case, in your test case, you can only have the test condition, test step, and expected result. You have not seen the application. So now, because the doctor, this is the receptionist that have taken the test condition. This is the step that the doctor himself, he hasn't seen. I have not called patient A. Now, this is it. So this is the test case. Now, the doctor has called in patient A. He's now asking him question, validating the question with what he has. Hence, this is what he gives him. So that's what stops it. And that's the way our test script is going to look at the end. So that will be it all for class tonight. And I'll say a wonderful thank you to you all, and time for our Q&A. So let me go to the question. So now start with the one I have here. Is this still under test case design? I don't know exactly. If you mean, yeah, they're still all under test case design. So that's the way we design our test cases. So, but prior to this, if you got any question, please let me know. Raise your hand, unmute and talk, and ask your questions, please. Because I've not seen any question on the chat currently. So if you've got any question, please let me know. Yes, Kobe, please, can you ask your question, please? Unmute yourself and ask the question, please. Are you able to?
Hello, can you hear me?
Yeah, I can hear you clearly.
Thank you. All right. Thank you for the lesson, first of all. I really appreciate that. My question is, Could you go over again what the main difference is between boundary value and equivalent class partition?
So let me go back to, I know you will ask the question, so let me go back to my slide. So I know it's kind of tricky, but though you'll still get it. I had to make it as simple as possible for you to get it. So now let's go back to equivalent partitioning. Let me take this one. So if you look at this, it's two things that we asked here. There are two conditions, 1 to 10. Forget and, use the word and. So there's nothing in between here and 20 to 30. So in this case, the reason why we are doing the equivalent partitioning is that we want to be able to test various conditions. But because we don't have, it's not that we can test all at once, but we believe that each of these subsets that we have divided, if we test it, it has already validated all the tests that we know, both negative and positive scenarios. Hence, we break it down into various places. It could be more than 10, it can be, but the major part here is 5 equivalent classes, differently. And the reason why I took them as a class is that minus from maybe minus to 0, minus 10, minus 9 to 0 is one subset, is one class. The next one is from 1 to 10, which is our valid scenario. Don't forget there is an and, yes, something stopping it, which is 11 to 19 is what is within that and. I need to also validate it, that so that in case when I am testing, if I take any number within that place, it shouldn't work. It should not work. It should show me an error because it's not part of the valid condition. This side, 20 to 30, is the valid part because that 20 to 30 is also part of my condition that for me to have a valid combination, a valid class, this 20 to 30 is between it. Then anything from 31 further down till infinity is invalid because it's not part of what is expected. So I'm testing between 1 and 10, 20 and 30. Anything outside it is not testing. So these 5 places that I have divided it, I just pick any number from there, which I said, this is it. So each of these that I have selected is what I'm going to use as my testing. They are my test data that I have created. That is what I'm going to use to validate the system or validate the data that I am testing. That's equivalent partitioning. So it's mainly, it allows you, it makes you divide. We have just talked about test condition, and this is what bets the test condition. So those test conditions are just these things here. So 3 to minus 2 is all these conditions. So with the minus 2, I will start testing with my minus 2 to make sure that when I test minus 2, anything from 0 down is not there. Now let's take it back to what boundary. For boundary, I will take it is you testing within the boundaries, testing both inside, outside the boundary. That's what it means. So for here now, we've got 1 to 10. 1 to 10 is what we want to test now. If you've got 1 to 10, we want to test outside the boundary, which is anything outside 1. Anything outside 1 is out the boundary. Anything from 1 to 10 is inside of the boundary. Anything at the back of 10 from 11 is outside the boundary. So that's why I'm looking at all edge cases within the boundary, outside the boundary, inside the boundary. So that is the reason why we now have 9, 10, 11. So remember, equivalent partitioning, you are picking edge cases within it. We have partitioned all your edge cases so that this is what I am going to test. This is the scenario I'm going to test. But when you are using boundary value analysis, you are casting around everything. Equivalent partitioning, I don't want to know what is in that thing. My valid part will be within that boundary, within that partition. So those are the ways. That's the way you say for equivalent partitioning and boundary value analysis. Understood, Kobe?
So for boundary value, you're just testing one result inside the boundary and one result outside the boundary.
Yes, but it's not really, one result outside, inside, but you have to test multiple ones. Like, I had to go one from behind, one exactly the same number, the one that is within, and also another one that is within, the exact one that I am starting from 1 to 10. I tested 0, I tested 1, and I tested 2. So just to make sure that if any of these 3 works, definitely I'm expecting 3, 4, 5, 6, 7 to work. That's the expectation. You can also, if you've got time to play with, you can also move to the middle and take 4, 5, 6. It's also a valid scenario, which you can now move again to say from 9, 10, 11, 12. It's also a valid scenario. You have to test within all those. All these are valid scenarios.
Mm-hmm. All right, yeah.
Yeah.
That makes sense. Thank you.
You're welcome. So, Kende, question, please. Kende, can you unmute?
Oh, yeah. I can't. Oh, hello. Hi.
Yeah.
Hi, Yemi. So what
Yeah.
I wanted to ask is regarding the sorry, I should have said thank you for the training. It's actually really nice and very interesting. So thank you. My question is with the test script. So once it's been written by the tester, how do you check whether it's correct, or do you take it to, I don't know, the developer, or how would you know it's all correct and right?
Okay. Oh, that's great. So when you design a script, you are following the requirement you've been given. Say, for example, you have been given a requirement by the business analyst. You all have a requirement that you're working with. So at that phase, when you are using that requirement, you will be writing your script. You have not seen the application. But with that requirement will state what you need. In your case, we are working in an agile environment. You will have a user story. And when you read the user story are going to be more of epic, big thing that will just give you 3 lines to say, as this person, in order to do this, I want to be able to access this. So that's what it's going to give you. But now there are acceptance criteria to now say. So you will now say, it will break down those acceptance criteria. You will now start dwelling on those acceptance criteria to write your own script. At that phase, when you're writing it, you've not seen the application. Now, you can't take your script to anyone. You own the script. The script is owned by testers. There are times that maybe your manager might want to do a peer review, or if you want to brainstorm, that's fine. You can take it. It's going to bring within the tester. And sometimes you can also validate with the developer, but most of the time, the onus is on you to, as a tester, to own it yourself, because you are working with the requirements. So it's the requirement that you're working. Now, not to worry, everything in the script might not be too correct because you've not seen the system. Now, when you start seeing the system, when you're giving the application, maybe then it was like you said, click on this. It may not be called submit button. It might be changed, maybe to login button. You need to now update your script to suit whatever you're seeing at that time. So that's the way it works. It's not really you giving your script to anybody. But the reason why we make it clear is that you might be off on the day you are needed. Someone else needs to pick the script. It needs to be well explained to the person. So we update the script as it goes along. So when you have the system, so you're able to update the script, you amend, you modify the script. That's the way it works. So
Yeah, thank you.
I hope,
Thank you.
okay, great. That's fine, Kenny.
Thanks.
Olamide, please.
Hello. Thank you, Yemi. I sincerely appreciate the lecture.
Go ahead.
I've got two questions.
Okay.
You talked about test case design. You know, on that test case design, we talked about specification based, structure based, experience based. Then when you explain the first two, from the first two, structure based, you went straight to categories of test case design techniques. You didn't explain experience based directly, so you went there straight to categories. Then under categories of test case design techniques, that was when you now explain about experience based. You talked about error guessing and another one under it. So that was why I asked if all of the categories, should be as well put under the test case design.
So everything is all under test case design technique. If you remember, I said there are three. These three are three test case design. They've delivered 3 children, which is that's the grandpa is as specific based technique. It's got the structure based technique, and it's got the error experience based technique. Now I took it one after the other. Specification based technique. That specification based technique has children. It has its own children, and those children are equivalent partitioning, boundary value analysis, decision table, state transition, and use case testing. All these are under specification based because they look up to specification based to get it. Now, structure based is more of a code part. That's what is a code part. Then the experience based, you also have 2 children, the error guessing and exploratory testing. So they are all the same technique, but I had to break it down because if I bring them together, if I'm not explaining to you that way, it won't sync because these things sync together. They all come together as one. So it's still the same 3 children that test case technique has. But the other one, the test case technique, have specification based, has its own children. The other one has its own, and the last one too has its own. That's the way it works. They are all test case technique.
Okay. I think I got that part now. I think you just subtitled by putting categories of test case design. Guess you only subtitled it. Then the question is, could you please explain what you meant by atomic? When you that was under writing good test cases, you said
ad hoc.
Yeah, you said attempt to make your test case atomic. What do you mean by that, please? Underwriting good test cases.
Okay. Let me just go back. Let's go back. Everyone's guessing. Okay.
Writing good test cases.
Okay, writing.
Yeah.
To make your, so what I just mean is just using a word, making it, when you say something is atomic, making it clear, crystal clear, concise, not no, simple as easy as possible. How atoms are. That's just a use of word at that phase. It's not that. It's just for me to make things kind of clearer for you. That's the word I used as atomic. It's not that, yeah, it's a word that I'm just using just for people to have a clearer view that this is what it is. Your test case must be clear, it must be simple, it must be understood. So that's what it's just all about. It's not mainly that is specific to anything, but for an atom, you know how atoms work, and that's just the reason I used it to make sure that your test cases are clear, simple. Everyone can understand it. We know how the atoms are, and that's the reason I used it from both the chemistry point of view. That's just it.
All right. Thank you.
Rexford, please.
Very immaculate presentation, Yemi. Just
Thank
a quick one to chip in the boundary equivalent partitioning. Supposing I'm testing BBC registration page, I'm being given the option to test to register under 13 and over 13. So for instance, if with the under 13, I make the age 14 years and the over 13, I make the age under 13, would you consider that to be equivalent partitioning?
You said, listen to what did he say? He said you should test where? You are testing the BB site under 13. That's your
Right.
test case, correct?
So if you make the age 14 and with the over 13, you make the age below 13, would you consider that equivalent partitioning?
Okay, so again, what you're trying to say now is that this, with that, under 13, I can put it here to say the first edge case I want to look at here is the invalid scenario. For boundary value analysis, all the ones I've given you are valid scenarios. You get what I mean? They are all valid scenarios. But in this equivalent partitioning, which I said is you testing under is one edge case. Is one edge case. So at that phase, can you use equivalent partitioning? No, you are testing within the boundaries. So you are going under, you are going below. That's your expectation. But it depends on what the requirement gives you. You said it here another. You want to test under 13. So for your equivalent partitioning, one valid scenario will be you testing 13 itself. That's one edge case. When you are testing anything after 13, that's another edge case, which is an invalid case, because from 13 upward, they are all adults. That's the expectation. I don't know, maybe that's what the requirement says, but you said under 13. So that is an invalid scenario. So my first scenario will be you taking from this part to say under 13, you've taken 12. That's one invalid scenario. The valid one exactly is 13. That's a valid scenario. Anything after 13, which is 14, is invalid. Now, you have to know when you want to use these techniques. When exactly is that technique valid? At that phase, that technique will be valid with boundaries, because you want to test every possible thing in and outside the combinations. That's when you use. So it's kind of equivalent partitioning and boundary value analysis are very tricky. So you have to be careful on what you want to use. And these things, you can say that I built this in classes. just for you to have more understanding, to see it in more clearer view. I used a login scenario initially to validate that, for you to see the reason why I explained that, because that's why I said alphanumeric, use names, do different combination. That is the different classes that I'm going to break it into. But with that undertaking, I would possibly say a boundary value analysis technique will be kind of good to use at that phase, because you want to break the system. You want to know what exactly what ages can use that application. So hence you will use that. If you use 1 year, a year-old baby should not be able to use the application. So that's also you testing out. And if you use 50 something, they should be able to use the application. So that's the essence. So it depends on what exactly your requirement is taking and what is expected from the requirement. I hope it makes sense a bit. Rexford.
Yeah, it does. Thank you very much.
So, sorry, I don't know if I can come in a little bit there.
Yes,
I
please.
think the scenario that you mentioned regarding less than age 13 is not a good one for equivalent partitioning based on what you have explained. I think that would be good for boundary value analysis, because you are only measuring, you are testing the behavior at the boundary, because they have been specific that it should not go beyond 13 years. So you test that 13 years is not accepted, 14 years is accepted, but not equivalent partition. It won't work well there.
Yeah, absolutely. That's fine. Thank you so much, Olu.
Thank you.
Yes, Abdul Ghaffar, please. Then after then,
Okay, thank you very much for.
Yes, please.
Thank you.
Yes, please.
I was wondering whether you were punishing me and Akinyemi. Our hands have been up since.
Oh, sorry.
Please. Okay. Please, on the slide that depict these are experience-based test design.
Mm-hmm.
Experience-based. Please, can you go to that slide, please? I want to pick out something there. Experience-based. Okay.
Mm-hmm.
Yeah. Okay. It's okay. Okay. I think in the first, you told us that there are 3 test case designs. The first one specific, the second one structure. Why this one is meant to be the third one. I think this is where it's confusing. Like somebody asked the other time. Before you
look at
numbered
it.
1,
This is
2.
experience-based testing.
Experience-based. Okay. All right.
So what I've done is that I only do this to remind you people, because these things are questions that, if you can see, that's I put number 3. I specifically said it. If from the beginning, if you look at it, it's going to be test case design technique. All these are all the techniques that we use. But because I like to, because this thing is tricky, if you can see, I went back to say test case design technique. It's still the same one. Look at it, structure-based, experience-based. The third one is this. If you look at
I
it.
now understand. That slide, I now understand. Now,
Yes.
thank you so much.
That's the way it is. No.
I now get it. Then I think I remember you said we are going to use Excel this evening.
We are going to Excel. We are going to use both Excel and Azure DevOps to do the
Okay,
manual. Not today, not in this class. We need to get this first. We need to get to this.
Thank you so much.
Yeah, not today. Yeah.
Thank you.
So, yeah, next person. Akinyemi, sorry. Akinyemi Ayokunle.
Yes. Thank you once again for this lecture. Please, my own is just a request, if possible, that today's training video can be sent immediately after this class, so that I can quickly go over it again
Okay.
I don't know if it is possible before we have, yeah.
I'll speak to I'll let them know so you can get the videos immediately.
Okay, thank you.
Yeah, that's fine. And also, I think from someone here, is experience-based technique a white box or black box testing? No, it's experience-based. So white box is more of a structured based technique, and black box is specification-based technique because you can see the requirement. You are testing against it. And the white box is more of a code base. So any other question? Emmanuel, please.
Hi, Yemi. Can you hear me?
Yeah, I can hear you clearly.
Okay. I just wanted to, mine's also a bit of a request as well. I just wanted to, if, are we going to be able to like access the slides on the presentation? Because I'm finding it a bit difficult to sort of like make notes and sort of listen to what you're saying at the same time. Obviously,
okay. Yeah, I could.
You are going to have access. You are going to have access to the video anyway. So I think the last request also, yeah, we'll try as much as possible to make the video ready. We don't normally release slides anyway.
Oh, okay, that's fine. No worries.
Yeah. So, any other question?
Okay, please, another request, please. Please, I want to make one request again. I want you to please, maybe subsequently, number your slides so that it will be easy for us to refer to if we want to ask questions sometime. You can just say, please, on slide 5, this, instead of, not being specific. Thank you. It's just a suggestion. Thank you.
All right. No problem.
Professionally, you don't number slides. Yeah, that is not done. It's not professional way to do things, actually. So that's where most of the slides will have a title, right? Then you can ask, you don't put number on slides. They are not what's it called? Handouts, right? Technically. Sorry.
All right, sir.
Okay, so any other question? In the absence of that, I'll just ask some questions before we go. So how many techniques that do we have when it comes to specification-based technique?
5.
First one, correct? First one.
Equivalence.
It is not equivalence. You've not finished?
Equivalence partitioning techniques.
Okay. Next one.
Boundary value.
Boundary value analysis.
User.
The third one.
User cases testing technique.
Use case testing technique. Yeah.
Decision table technique.
Decision. Okay. Decision table.
Data transition.
Yeah.
And technique.
Correct. So, and also for experience-based, how many did we talk about this evening?
Error guessing exploratory.
We have
talked about 2.
Okay, yeah, that's
sorry. Some text questions have not been answered, please.
Oh, sorry. Okay. Sorry, let me see.
I sent for BV techniques. Does it mean that you said that we need 4 digits? So by using the boundaries, we ended up with 10,000, which is like 5 digits. So those areas are not so clear.
Yeah, because boundary, you have to test. That's why I said boundaries. You are testing.
Un jeune ingénieur africain se fait empoisonner à 3 reprises.
Can you mute, please? Okay. So with the boundary, so if you've got 10 boundary, I used 1,000 to 9 1,999. You are testing the boundaries.
Yeah.
Outside, inside, outside. Outside of 1,000, before you get to 1,000, is 999.
Yes.
Inside is 1,000. Anything inside again, 5,000, 500, 5,000 is inside the boundary. Outside the boundary again is add 1 to 999. We give you 10,000. You can also test 10,500 because that's also out of the boundary. So that's the reason. So you are testing outside, inside, outside. That's the way it's done.
Okay, thank you.
Yeah.
Sorry, just a quick one. Sorry. Can you hear me?
Yeah, I can hear you. Sorry, Kabi.
All right, thanks.
Go on.
So for boundary, you're literally just testing around the boundary. You're not varying too much. So if you are testing at, let's go with that 1,000 with the 4 digits. So you're testing 1,000, you're testing 999, which is inside the boundary, and 3 digits. So is that basically the premise? You're just testing around the boundary. You're not
around the boundary. You are also testing in between it, inside it, because if you don't, you want to check that every possible test cases are validated. Must be validated. That's the essence of you checking all this, doing all this check. Okay, you've got 9,900. You want to start testing it one after the other. You're going to test 1 to 10, 10 to 100, 100 to 1,000, 1,000 to 2,000. So it's because we can't be testing all those edge cases one after the other. Hence, we need to get some subset of the test that we believe is going to cover everything that we are meant to test. Hence, that's the reason of this. So now you have tested the 3 values. You've tested the value within the boundary. You've tested outside, inside, outside, inside. Do you get it now?
Yeah.
So what I mean is, you've got 1,000. We want to use boundary value analysis. You have tested 1,000 is between 1,000 and 999. That's where we are meant to test. But we need to be sure that we've got all possible scenarios covered. Hence, we have for the we've tested outside of the boundary. Always remember, for boundary, you have to go outside, inside, outside, inside, outside. So that's the way it's done. So
yeah, thank you.
Yeah. Any other question? So in the absence of no question,
please.
Okay. Who is that? Yeah, let's go for it, please.
Okay, all right. Oh, for boundary value, please. Is it a strict policy or just an advice to for values?
Is it a what?
A strict policy, or it's just an advice to use 3 to 4 values in boundaries? Boundary values.
No, where you're getting it is that it's an example. It can be in form. You are not. It could be in any form. In any form. That's where, because these examples are test. Therefore, used when you start designing your test case. I'm not going to use 1, 2, 3 when you start designing login. When you start testing a website, I'm not going to use those values. But just for simplicity, for clearer view, that's the reason we use this example, so that it gets. When you see things in a smaller version, you get a more understanding of it. When you are testing a website, I can't bring 1, 2, I can't say 4 letters of this. But there are things that you're going to test using the boundary. You're testing your login criteria. You've got the acceptance criteria that express some expectations. So all those things are the things that you look into when it comes to it. It's not that it's strictly for value. No, it could be anything. So you need to now derive your own cases when it comes to that.
Thank you.
So the video is live on YouTube. Okay. So with clinic scenarios, they would get it better. Okay. Someone said I should relate it to clinic scenarios that you get it better. So it's just like if I relate it to clinic scenarios, it's just more like what I said about the doctor when the patient went for stomach pain and they've gotten to the doctor. He only used those edge cases to prepare himself down so that when the patient with stomach pain comes, I would have touched all the possible scenarios that happen to the stomach pain. So now patient A has gone to meet the doctor. Before he went to meet the doctor wants to know each edge case that could cause the stomach pain. That's the reason. So bring it to that boundary. I'm not using numbers now. I'm using what the doctor is going to ask the patient. Now the patient has seen the doctor. He wants to look, okay, I've checked what can happen. Physically, if I touch the stomach, is it paining you? That is outside the boundary. Inside the boundary, how the patient is feeling inside. Did you drink something inside your stomach that made it? That is inside of you. That is inside the boundary. Outside the boundary, is anything irritating you that is causing it? Maybe that's physically. That is the way it works. So this time around, I didn't use numbers. I'm using what the patient has seen as the doctor. So that's it. Any other question before we close the class tonight? So in the absence of no question tonight, I'll see you all again tomorrow. Thank you all for your time. And do we use all this technique at once while testing? No, it depends. We don't use it it's not at once. So it depends on what you are, whenever you're testing, what the projects are like, then you can try to use these techniques against it. So thank you all for tonight's class and hope to see you all tomorrow at the same time. Have a wonderful evening. Goodbye.
Thank you very much.
Thank you very much.
Thank you.
Thank you.
Good night.
Good night. Thank you.
Go for it. Do you want to try?